Okay, good morning.
Good
Good
morning,
morning,
sir.
sir.
Okay, fine, fine. So, in the class, can you see the slide?
Yes, sir.
Okay, fine. So, in the last class, we were discussing about the supercharger, and at the last, we discussed about the turbocharger. Hope you understand. Is there is any doubt for that? ഒരു doubt ഉണ്ടോ?
No, sir.
Okay. The recording is going on, right?
Yes, sir.
Okay, fine. So here we discuss about the supercharger. Okay, the main difference between these two is the nothing but this particular supercharge will be taking power from where?
Exhaust.
No, that is about turbocharger. I am saying about the supercharger. Supercharger will be taking the power from the crank itself. Okay, using the gear or any other belt drive or etc. They will be taking the uh, they'll be taking this particular power from this engine itself. So like the then as a result the brake power will be little bit less, but here you have to understand still the brake power will be greater than an engine without supercharger, understood? Understood?
Yes, sir. Yes, sir.
Okay, so in the case of turbocharger, here we are not taking any power from power from engine. Okay, instead of that we are utilizing the exhaust, yeah, exhaust gas. Okay, then this exhaust gas will be spinning the turbine. Okay, and this particular thing happens to, like, it will be pressurizing the atmospheric air. And one more thing you have to add here is as the pressure increases, the temperature also increases. So in order to reduce that particular temperature, we are using an air cooler. Sorry, after cooler, or as well as we will also call it as intercooler. Okay, so then this particular hot air will be, or hot air get cooled. Okay, then it is given to the chamber. This is the process. Okay, so here while explaining this particular supercharger as well as turbocharger, you first of all you have to start with the mean effective pressure. Okay, then what are the conditions for that particular thing? Okay, the maximum power and everything you can say that, then you can write this equation, and you can just explain why we are not considering these two, and we cannot consider this due to the fuel economy and the frictional loss or frictional power loss. Okay, so we have to control this particular factor in order to increase the power output. Okay, this were the last topic we discussed in the last class. Okay, so the classifications is that, and for this classification I didn't see a question of this particular to define this all these things, but still I will be sharing a pdf for you. Okay, and you can note it down in your note, each centrifugal rotor and wheel. It is very simple one, so we don't need to lead just a simple topic which give us mark. Okay.
Okay, sir.
Okay, so then now we are going to discuss about the benefits of supercharger. Okay, so as we told that the what is when we supercharging means, we already discussed, we are increasing the density of the air intake. As a result, what will happen? The efficient combustion of the fuel taken place. As a result, we will be getting more power. Okay, so that was the first one itself. Okay, here the density of the intake air increases, as well as a result the mass. of airtake increases, and we know that as a result the volumetric efficiency will be increased. Sorry, the volumetric efficiency will be increased. So here, first of all, volumetric efficiency, you have to remember what is the volumetric efficiency. We already discussed about it. Is we can, if you remember, or I will just give an definition for that. It is a ratio of actual volume of the charge drawn in the chamber or in the drawn during the suction stroke. Okay, actual volume of the charge drawn in the suction stroke or during the suction stroke divided by the septic volume. Okay, അതാണ് വോളിയോമെട്രിക് എഫിഷ്യൻസി എന്ന് വെച്ചാൽ എന്താണ് വോളിയം ഓഫ് ദ ആക്ച്വൽ ചാർജ് അഡ്മിറ്റഡ് ഡിവൈഡ് ബൈ ദ സെപ്റ്റി വോളിയം. ഓക്കെ, അതാണ് നമുക്ക് ഈ ഒരു വോളിയോമെട്രിക്. അപ്പോൾ വോളിയോമെട്രിക് എഫിഷ്യൻസി ഉണ്ട്, അതേപോലെ തന്നെ റിലേറ്റീവ് എഫിഷ്യൻസി ഉണ്ട്, മെക്കാനിക്കൽ എഫിഷ്യൻസീസ് ആർ ദ. സോ ബി തറ വിത്ത് ദ ഫോർമുല ആസ് വെൽ ആസ് ദ യൂണിറ്റ് changes also. So today I will be sharing few questions. Okay, you can take down that, and you have to write it down or solve it down in your tutorial note. Okay, and if any doubt you can contact me, and I think it will be better if you know the, it will be easy if you know the particular formula for each volumetric efficiency as well as the indicated power, brake power, and everything. Okay, so next what, as the result, the second benefit is that the mean effective pressure increases. We all know that the efficient combustion rate, the power output increases, as well as the thermal efficiency increases. Thermal efficiency also increases. So what do you mean by thermal efficiency? Do you remember thermal efficiency? ഏയ്, ഞാൻ അന്നേ പറഞ്ഞത് ഇത് എടുക്കുന്ന സമയത്ത് യു ഹാവ് ടു നോ ദിസ്, ലൈക്ക് the energy supplied. Okay, this will be our input. Okay, then as a result what will happen here, the input, the power obtained, it it can be indicated power or brake power. Okay, so this is our formula. ഓക്കെ, മനസ്സിലായിനോ? അതായത് എന്താണ് ഈ തെർമൽ എഫിഷ്യൻസി എന്ന് വെച്ചാൽ എന്താണ്? ഇറ്റ് ഈസ് ഡിഫൈൻഡ് ആസ് ദ റേഷ്യോ ഓഫ് ദി ബി പി ഓർ ഐ പി. അതായത് എന്താണ്, ബ്രേക്ക് thermal efficiency ആണെങ്കിൽ we will use brake power, and in the case of indicated power, the indicated thermal efficiency, we will be using the indicated power, okay, to the energy supplied by the fuel. So here the fuel ആണ്, ഈ energy supplied by the fuel means it will be we'll be using the mass flow rate of the fuel into the calorific value. Okay, this will give the energy supplied or the energy given by the fluid. We already discussed it, so I am not taking a lot of time. If you not remember, you can see the previous videos. Okay, so here the as a result, the more power output is obtained from for the same ഡിസ്പ്ലേസ്മെന്റ് വോളിയം അല്ലേ. നമ്മൾ ആ ഒരു ഡിസ്പ്ലേസ്മെന്റ് അല്ലെ നമ്മൾ ആ സിലിണ്ടറിലേക്ക് നമ്മൾ എന്താണ് പ്രഷറൈസ്ഡ് എയർ ഈസ് ഗിവിംഗ്. ഓക്കെ, ആസ് എ റിസൾട്ട് ദ എഫക്റ്റീവ് കമ്പസ്റ്റൻ ടേക്സ് പ്ലേസ് ആൻഡ് മോർ പവർ ഈസ് ഗിവൺ. ദ സെയിം തിങ് ഈസ് ദാറ്റ് if we are taking a same size or same displacement volume, the power obtained will be more. So here actually the pressure is increasing, right? So there will be so many load acting on the piston. Okay, so we are going to discuss about the demerits of this particular supercharger. So first one is the more mechanical load, and the more frictional power or frictional loss will be increased, and the cost and complexity of that particular engine will be increased. So these are the main things. So while writing, you have to add on these all points. Understood? Hello? Hello?
Yes, sir.
Okay.
Sir,
Okay. ഒരു കാര്യം മനസ്സിലാക്കേണ്ടത് എന്താണെന്ന് വെച്ചാൽ ഈ ഒരു ഇതിലുള്ള പ്രോബ്ലംസും കാര്യങ്ങളൊക്കെ വരുന്നത് ഈ ഒരു തെർമൽ എഫിഷ്യൻസി, ദെൻ മെക്കാനിക്കൽ എഫിഷ്യൻസി, റിലേറ്റീവ് എഫിഷ്യൻസി, വോളിമെട്രിക് എഫിഷ്യൻസി, ദെൻ ദ ഫോർമുല ഫോർ ഇൻഡിക്കേറ്റഡ് പവർ, ബ്രേക്ക് പവർ, ദെൻ ദ റിലേഷൻ ബിറ്റ്വീൻ ദി so the relation for the pressure, frictional power, everything we already discussed the parameters. Okay, then specific fuel consumption. Okay, and what is meant by the brake, like in the thermal efficiency also we will be using the brake thermal efficiency as well as indicated thermal efficiency also. So ഇതൊക്കെ അത്രയും സിമ്പിൾ ആണ്. സോ ഫസ്റ്റ് ഓഫ് ഓൾ യു ഹാവ് ടു ഗോ ത്രൂ ഓൾ ദിസ് തിങ് ടുഡേ ഇറ്റ് സെൽഫ്. Okay, then only you will get a clear idea of over this particular module. It's a very simple module actually. Okay, so now we are going to move in the performance testing of IC engines. Okay, so still now we were discussing about the so many factors, or like so many factors we use to understand the performance of an IC engine. So for understanding all these things, we are conducting so many tests. Okay, a test for this particular how what is the brake power of a particular engine, or what will be the indicated power of a particular engine. Okay, so that we are going to discuss about, we had to study three tests in this particular module, which is cited over your syllabus. Okay, so the first one is that Morse test. Do you remember, or do you ever heard about this particular thing? Hello, do you have thermal engineering lab? Hello,
Yes, sir. Curtain lab.
ചെയ്തിട്ടുണ്ടോ? Do you ever say that?
Yes, sir.
Okay, fine. So you will be familiar with. So actually, the for what we are doing this particular masters. Okay, tell me for what we are using this particular masters. Hello, അറിയാവോ?
To find the
To find the,
indicated power of each cylinder.
yeah, indicated power of,
Each cylinder.
yeah, okay, fine. So here, actually, this particular test is conducted for finding the indicated power. Okay, actually, we know that indicated power means the power developed in the cylinder itself. Okay, so indicated power, then that particular power will be transferred to the, or it will be converted into the kinetic motion of the piston, and from there it will be transferred to the crankshaft. At this time there will be a frictional loss, because from the piston to crankshaft there the mechanical parts get into the action. As a result there will be so many frictional losses, and we will be obtaining a power to the, or power on the crankshaft, and which is known as brake power. So this is the nutshell for about this particular power. Three powers is acting here. So here actually we are going to find the indicated power. Okay, so this particular test is used to find the indicated power of a multi-cylinder engine. Okay, multi-cylinder engine means which having more than one cylinders. So this is very simple. Okay, നമുക്ക് just calculation മാത്രമേ ഉള്ളൂ, and based on this there is a few problems also there, and which is very very simple. Okay, so first of all they will be asking to find the indicated power in the question. Okay, then they will be asking to find the volumetric efficiency, or they will be asking to find the fuel consumption of that. Everything will be easy if you are familiar with the formula first of all. Okay, so if you have any doubt, okay, you can ask me about the formula, like in personally, or okay, you can ask me after this particular class. Okay, then I can give you already we discussed it, and I can give you some PDF also, and it will be better for you for the learning. Okay, so here the first one is, you have to understand that here the this particular test is used to find the indicated power of the each cylinder. Okay, each cylinder of, just wait, there is a mistake. I think is adopted to find the indicated power of each cylinder. Just wait, okay. Each cylinder of a multi-cylinder engine. Okay, that's enough. Okay, so here, first of all, you have to understand that we are not using any indicator diagram for this particular thing. So it is very simple. Okay, so just think. Okay, here, how many cylinders are here?
4.
Yeah, four cylinders are here. Okay, so it is very simple that first of all we will start this particular engine and we will make to run this particular engine in a rated speed like we can choose this at one. Okay, 1500 rpm. Okay, 1500 rpm we will make to run this particular thing. Okay, then at that time first we will make this by using the So by using the rope, brake, dynamo, and everything, we will be applying load over this particular, and we will be making or we will be start this engine and make this engine run in the rated speed. Okay, let it be 1500 rpm. Okay, so here at that time, the all the four cylinder will be working. Okay, so then at that time we will be finding the brake power. We will be finding the brake power. So first of all, we find the brake power. Just 1 minute. Oh, hello, hello. Sorry, sorry. Hello, can you hear me?
Yes, sir.
Sir,
Yes,
Okay,
sir.
okay. Sorry, sorry. So here നമ്മൾ നിങ്ങൾ എവിടുത്തെ വരെ കേട്ടിട്ടുണ്ട് ഇത് ബ്രേക്ക് പവർ മെഷർ ചെയ്ത വരെ കേട്ടോ? Hello.
brake power will do it.
Okay, so at the first time we will measure the all the like we will make run the all the cylinders and we will be measuring the brake power at the rated speed. Okay, then after that, then we will be cutting off that particular cylinder one. Okay, so cylinder one will be we can cut by how in the case of a petrol engine we will be cutting out the spark plug or we will be cutting out. We are not removing that. We will be just remove the circuit or we will be just hold it in any other ways. Okay, in this case of a diesel engine we will be arresting the function of that particular fuel injector. Okay, so as a result what will happen here, the fuel or the charge will not be here and the to and fro motion or the power will not be developed in the cylinder one. Understood?
Yes, sir.
Okay, but still you have to understand that this particular cylinder is connected with a shaft, right?
Sir.
Yeah. So I am asking that whether if this particular engine is not producing the power, will it work or not? Understood?
Sir. Yes.
Oh, my question is that we already cut the fuel flow to the cylinder one. Okay. So I am asking that due to that particular thing, whether this motion of this piston will be there or not.
No.
No.
Yeah. I am not clear. Can you please tell me?
No, sir.
ഉണ്ടാവില്ല.
sir.
യെസ് ഓർ നോ?
ഉണ്ടാവില്ല.
ഉണ്ടാവും. എങ്ങനെ ഉണ്ടാവും? എങ്ങനെ
Sir, ഉണ്ടാവില്ല.
ഉണ്ടാവില്ല? ഓക്കെ, എനിവൺ? അസഫ്, ഉണ്ടാവോ ഇല്ലേ? ദ മോഷൻ ഓഫ് ദാറ്റ് പർട്ടിക്കുലർ എഞ്ചിൻ, സോറി സിലിണ്ടർ,
ഉണ്ടാവും.
ഉണ്ടാവും. ഓക്കെ, വിഷ്ണു എ പി?
സർ ഉണ്ടാവൂലേ?
ഉണ്ടാവും. ഉണ്ടാവും എന്നല്ലേ പറയുന്നത്?
ആ
Okay, fine. Yeah. So you have to understand what here that particular motion will be there because this all these engines are connected with a shaft. So as here this particular motion of the cylinder 2 or the piston of the cylinder, piston cylinder 2, 3 and 4, everyone will make that particular power also. So as a result you have to understand that here the movement of that piston inside the cylinder one after the cutoff also, after the cutoff also there will be the motion of the particular piston. So here the motion is there. So the indicated power will be 0. But what about the frictional power? What about the frictional power?
ഉണ്ടാവും.
ഉണ്ടാവും. Because there is a motion. Okay, അവിടെ ഒരു motion ഉണ്ടല്ലോ already അല്ലേ?
Sir.
So similarly, okay, then yeah, after this we will be do okay, after the cutting of the cylinder 1, what happened? The speed of the engine decreases. That means the rated speed will be decreased. For that we can say the rate of that particular speed will be 100 200 1200 rpm. Okay, so then we will be making that particular, we will be arranging this setup, this rope brake dynamo, and we will be adjusting the load and make the particular engine again to the rated speed. Understood?
Yes, sir.
Okay, at that time then we will be measuring the braking power. Okay, at that time then again we will be measuring the braking power. So this particular braking power will be the power obtained after the cutting of the cylinder 1, cut off. Okay, cut off of cylinder 1. Okay, understood? First
Yes,
of
sir.
all, we will be getting the braking power of the engine while the 4 cylinder is working, and next we will be getting what? The braking power of engine when the cylinder 1 is arrested. Then what will happen? We will be arresting the working of, or we will be cut offing the cylinder 1 and 2 and 3. Similarly, we will be obtaining this much things. Okay, right? Right?
Sir.
Okay,
Sir.
fine. Okay. So here we are taking IP1, IP2, IP3, IP4, etc. as indicate power of each individual cylinder. And frictional power for individual frictional power we will be taking a P1, FP2, FP3 like that. And BP1, BP2, BP3 and BP4. Okay. For the brake power of individual or each cylinder. Okay. So So here, first of all, we will be taking the total brake power. Okay, total brake power will be the, we already know, indicated power equal to brake power minus, okay, so the brake power equal to indicated power minus FP. Okay, so here we will be getting an equation for this. BP equal to IP1 plus, okay, the 4 individual cylinder minus the friction developed in the each cylinders, right?
Yes, sir.
Okay. So if we are cutting the first cylinder, okay, first cylinder means what happened? this becomes 0, right?
Yes, sir.
Yeah, so the BP of remaining three cylinders will be BPIO equal to IP2, IP3, IP4 minus FP1. FP1 is there because since the indicator power is not there, these all cylinders are connecting with a single shaft. As a result, the motion will be there itself. So the frictional power also or frictional loss will be there. Okay, the frictional power of each cylinder. So what will be getting? We will be getting B പി ഐ സി ഒ ബിക്കോസ് ഈ ഒരു ടേം നമുക്കറിയാം ഓൾറെഡി നമുക്ക് ഇതറിയാലോ ഇതിൻ്റെ അകത്ത് ഏതാണ് സീറോ ഈ ഒരു പർട്ടിക്കുലർ P1 മാത്രമേ സീറോ ഉള്ളൂ സോ ഇഫ് വി ആർ ഗെറ്റിംഗ് ദിസ് BP ആൻഡ് BP1CO we can if we are subtracting this we will be getting the IP1. Understood?
Yes, sir.
Okay, understood. Yeah, Sarun.
Yes, sir.
Okay. സോ സിമിലർലി എന്താണ് നമുക്ക് ആ ഓരോന്നിൻ്റെ അല്ലേ നമുക്കിപ്പം BP1 അറിയാം അല്ലെ BP1CO അറിയാം BP2CO അറിയാം BP3CO അറിയാം സോ ഈച്ച് ദിസ് പർട്ടിക്കുലർ ബ്രേക്ക് പവർ ഇഫ് യു ആർ സബ്സ്ട്രാക്ടിങ് ഫ്രം ദ BP which is the brake power obtained while four cylinder is active we'll be getting the corresponding IP1 or here we will be getting the IP2 here we will be getting the IP3 and we will get in the IP4. Okay, so the total indicated power, the total IP will be IP1 plus IP2 plus IP3 plus IP4. Okay, understood?
Yes, sir.
Okay, so thereby we will be getting the indicated power of each cylinder of a multi-cylinder engine. Okay, understood? So this was our motive, right? Understood?
Yes, sir.
Yes, sir.
Okay, very good. So this is the procedure. Okay, in few examination, I found that there was a question to in order to write that particular procedure also. So while explaining the procedure, the mark for that particular thing came for the 5 or 7 or something like that. So it is not a short answer. So while writing the procedure, you have to give this all this data. Okay, and it will be very simple for you if you are understanding this particular thing. Okay, ഇത് മാത്രം മനസ്സിലാക്കിയാൽ മതി this one. Okay, individual item. Then if IP is 0, this 2 is if you can understand, and you will be getting that particular question. Okay, so next we are moving to a question. Okay, next we are moving to a question. The question means just read that question. Do you understand? Here, what is the brake power? What is the brake power with all cylinder working?
13.
What is the yeah
13 kilowatt.
yeah so first of all you can write all these things. Okay, so here BP is equal to 13 kilowatts. Okay, then with the first cylinder cutoff we will be getting a BP as 9.3. So BP1CO equal to 9.3 kilowatt. Similarly, BP2CO equal to then say second cylinder cutoff we will be getting a brake power as 9.5. Then tell me about the B3. B3 എത്രയാണോ BP3
9.05.
okay, then what about the next one?
9.15.
9 point 15
15.
kilowatt. So yeah, okay. We all get this. Okay. So here they are asking determine the IP of the engine. Determine the IP of the engine. Okay. So IP we all know that, right? Okay. So we will be subtracting this BPO BP minus BP1 CO. Okay, then we will be getting IP1. Okay, similarly, BP minus BP2 CO equal to IP2. Similarly, BP minus BP3 ICO we will be getting IP3 and IP4. So, sum of these all will be giving the indicated power of the engine. Understood? Understood?
Yes, sir.
Yes,
Okay.
sir.
Yeah. ഇതുവരെയുള്ളതിൽ നമുക്ക് വേറെ പ്രത്യേകിച്ച് കാര്യങ്ങളൊന്നുമില്ല, അതായത് ജസ്റ്റ് സിമ്പിൾ മാത്തമാറ്റിക്സ് ആണ്. ഓക്കെ, സോ നെക്സ്റ്റ് ദേ യൂസ് ടു ആസ്ക് ദാറ്റ് ഡിറ്റർമൈൻ ദ ഇൻഡിക്കേറ്റഡ് തെർമൽ എഫിഷ്യൻസി. സോ ദേ ആസ്ക് indicated thermal efficiency. Okay, thermal efficiency. So first of all, you have to know what is, we already discussed about the thermal efficiency. Thermal efficiency means the energy. Okay, here they ask as the indicated energy divided by the energy supplied. Okay, energy supplied to the engine. Okay, so the energy is supplied to the engine in the form of what? Energy
Fuel.
is supplied, yeah, fuel. So the energy given by the fuel will be, we will be getting the mass flow rate into calorific value of the calorific value of the particular fuel. Okay, so if here the question comes in the indicated power, right? In the they asked to determine the indicated power, or they will be asking the brake thermal efficiency also. So at that time what will happen? Instead of indicated power, brake power will be using. Okay, so this is the thing. So here you have to understand that here it will be this particular thing. Okay, actually this must be in the kilogram per second. Okay, so in most of the question, the question will be coming in like giving in the terms of kilo hour. Okay, so kilo hour will be the asking. എല്ലാ ക്വസ്റ്റ്യനിലും അധികം എന്താണ് കാണുന്നത്, ഇപ്പോൾ ഫോർ എക്സാമ്പിൾ ലൈക്ക് 2 കിലോഗ്രാം പെർ സെക്കൻഡ് ഒക്കെ ആയിരിക്കും കാണുക മാസ് ഫ്ലോ റേറ്റ്. അപ്പോൾ ആ മാസ് ഫ്ലോ റേറ്റിന്റെ കേസിലേക്ക് നമ്മൾ എന്ത് ചെയ്യണം? നമ്മൾ എപ്പോഴും വി വിൽ ബി കൺസിഡറിങ് ദറ്റ് പർട്ടിക്കുലർ കിലോഗ്രാം പെർ അവർ ആയിട്ട് ഇവിടെ കൺസിഡർ ചെയ്താൽ മതി. സോ ഇഫ് യു ആർ കൺസിഡറിങ് ഹിയർ ദ മാസ് ഫ്ലോ റേറ്റ് ഈസ് ഇൻ ദി kilogram per hour, അവറിലായിരിക്കും ക്വസ്റ്റ്യൻ ഉണ്ടാവുക. സോ ബട്ട് വൈൽ ഡൂയിങ് വി ഹാവ് ടു consider it in the seconds. So we will be adding we will be dividing that particular thing with the 3600. Okay, then it will be going to the denominator. Okay, so the particular thing will be, wait, so the indicated thermal efficiency will be IP into 360 divided by MF into calorific value. Okay, this here it must be in kilogram per hour. Okay, so here it is given in minute. Okay, ഇത് ആക്ച്വലി ഇവിടെ സെക്കൻഡിലാണ് വേണ്ടത്, പക്ഷെങ്കിൽ അധിക ക്വസ്റ്റ്യനിൽ എന്താണ് അവർ ഉണ്ടാവും. സോ വി ആർ ആഡിങ് ദിസ്. ഓക്കെ, ഇതിപ്പം ഇവിടെ ക്വസ്റ്റ്യനിൽ എന്താണ്, ഇവിടെ എന്താ തന്നിട്ടുള്ളത്? മിനിറ്റിലാണ് തന്നിട്ടുള്ളത്. ആ മിനിറ്റിന് എന്ത് ചെയ്താൽ മതി? നിങ്ങൾ അവറിലേക്ക് കൺവേർട്ട് ചെയ്താൽ മതി. അല്ലെങ്കിൽ ഒരു കാര്യം ചെയ്യുക, എന്താണ്, അതർവൈസ് യു ക്യാൻ ഡയറക്ട്ലി റൈറ്റ് IP into MF into CV, where this particular thing must be in the kilogram per second. ഓക്കെ, അങ്ങനെ നിങ്ങൾക്ക് അവോയ്ഡ് ചെയ്യാം, ഇങ്ങനെ എഴുതിയാൽ മതിയായിരുന്നു. പക്ഷേ മോസ്റ്റ് ഓഫ് ദ ക്വസ്റ്റ്യൻ ഇറ്റ് വിൽ ബി കമ്മിങ് ഇൻ ദ ഫോം ഓഫ് കിലോഗ്രാം പെർ അവർ. Okay, അത് മാത്രമേ നമുക്ക് ഇവിടെ ഒരു ഇക്വേഷൻ ആയിട്ട് പറയാനുള്ളൂ. So we will be from this whole thing, if we are subtracting these things, we will be getting the indicated power. We will be getting this indicated power. Okay, indicated power കിട്ടും. Then we already the particular calorific value is given. Okay, calorific value is given, and the conversion of this particular MF or the fuel consumption must be taken place. Okay, so it will be giving an equation will be after substitution. The equation will be like ip into 360 divided by mf, which is in kilogram per into 41450. Okay, so this will be the, it will give you the thermal, sorry, indicated thermal efficiencies. Okay, understood?
Yes, sir.
Okay, so this is in the afternoon class. Okay, we will be discussing another question also, and this you can just have a screenshot of this particular thing also. ഇതും കൂടി ഡിസ്കസ് ചെയ്യുന്നുണ്ട്. അത് ഡിസ്കസ് ചെയ്തിട്ട് നമുക്ക് എന്ത് ചെയ്യാം, we can wind up this section. Okay, just it will take only 3 minutes. Okay, shall we go?
Sure.
Sir.
Okay, okay, fine. So here they are giving like an engine developer 5.4 kilowatt of power with its indicated thermal efficiency and mechanical thermal efficiency are 36% and 78%. Estimate the fuel consumption of the engine, and the indicated specific fuel consumption and brake specific fuel consumption. Okay, so here given that the brake power, the engine developments, it will be the brake time ആയിടോ അറിയാം, അതുകൊണ്ട് ഒരു 4 മിനിറ്റ് ഒന്നും കൂടി പറഞ്ഞു. Okay, the brake power will be 5.4 kilowatt and the thermal indicated thermal efficiency is 36%. Okay, and the mechanical efficiency will be given as, or it is given as 76%. Okay, and the calorific value is given as 41,100 kilojoule per kilogram. Okay, so first of all what we have to find the, ഇവിടെ എന്താ ചോദിച്ചിട്ടുള്ള, ഫൈൻഡ് ദ ഫ്യൂവൽ കൺസപ്ഷൻ ആണ്. ഫ്യൂവൽ കൺസപ്ഷൻ കാണിക്കൽ നമുക്ക് എന്താണ്, ഇവിടെ എന്ത് തന്നിട്ടുണ്ട്, ഇൻഡിക്കേറ്റഡ് തെർമൽ എഫിഷ്യൻസി തന്നിട്ടുണ്ട്. സോ ഇഫ് യു ആർ റൈറ്റിംഗ് ദ പർട്ടിക്കുലർ ഫോർമുല ഫോർ ഇൻഡിക്കേറ്റഡ് പവർ, ഇറ്റ് വിൽ ബി IP divided by MF into CV. അല്ലെ, this is given. Okay, and this is also given. We have to find this particular MF. Okay, but here the indicated power is not given. Okay, instead of that we are given with the mechanical efficiency as 78. What is meant by mechanical efficiency? Mechanical efficiency, hello, mechanical
BP by
efficiency.
IP.
Yes, BP by
MF
IP.
into
അല്ല, മെക്കാനിക്കൽ എഫിഷ്യൻസി ആണ് പറയുന്നത്, BP by IP അല്ലേ, അല്ലെ? നമ്മുടെ പിസ്റ്റൺ എടുക്കുന്ന മുതൽ എന്താണ് ക്രാങ്ക് ഷാഫ്റ്റ് എത്തുന്നവരല്ലേ, ഇവിടെ എന്താണ് IP ആണ്. അപ്പോൾ ഇവിടുത്തെ ഇൻപുട്ട് ഏതാണ്, IP ആണ്. ഔട്ട്പുട്ട് ഏതാണ്, BP ആണ്. ഓക്കെ, ഈ ഒരു ലോസ് കാണിക്കാൻ കാരണം എന്താ, ഫ്രിക്ഷണൽ പവർ ആണ്. സോ ഹിയർ വി ക്യാൻ റൈറ്റ് ഇറ്റ് ആസ് IP equal to BP divided by, okay, so this particular BP is given in the question, as well as the efficiency of the mechanical efficiency also given. So it is like 541 divided by 0.78. Okay, so then we will be getting the particular IP also. Okay, so here the IP we can substitute here, and we then we will be knowing all the terms. Okay, indicated thermal efficiency and IP as well as CV. So we can, after rearranging, we will be getting the mass flow rate of the particular or the fuel consumption of the engine. fuel consumption of the engine. Okay, then indicated specific fuel consumption. So it indicated here specific fuel consumption. Do you remember what is specific fuel consumption? Okay, do you remember? So it is nothing but the fuel consumption per unit time divided by power. Okay, so the power can be indicated power or what? BP. So here they are asking about what? They are they asked about the both. Okay, indicated specific fuel consumption as well as the brake specific fuel consumption. Okay, so we will be the fuel consumption per unit time not on the hello
Yes, sir.
hello മനസ്സിലാവുന്നില്ല ഇതുവരെ പറഞ്ഞത് മനസ്സിലായിനോ
Sir.
ഓക്കെ ഇനി ഈ ഫ്യൂവൽ കൺസപ്ഷൻ എന്ന് പറഞ്ഞാൽ എന്താ സ്പെസിഫിക് ഫ്യൂവൽ എടാ ഫോർമുല അറിയാത്തതിന്റെ പ്രശ്നമാണ് വേറെ ഒന്നുമില്ല സ്പെസിഫിക് ഈക്വൽ ടു മീൻസ് ദ ഫ്യൂവൽ കൺസപ്ഷൻ ഓക്കെ കൺസപ്ഷൻ പെർ യൂണിറ്റ് ടൈം ഡിവൈഡ് ബൈ പവർ അല്ലെ ഈ ഫ്യൂവൽ കൺസപ്ഷൻ പെർ യൂണിറ്റ് ടൈം എന്ന് വെച്ചാൽ എന്താ അതിന്റെ ഇത് തന്നെയല്ലടാ മാസ് ഫ്ലോ റേറ്റ് തന്നെയല്ലേ ഓഫ് ദ ഫ്യൂവൽ അല്ലേ ഡിവൈഡ് ബൈ പവർ ക്യാൻ ബി IP or BP. Okay, so here they ask the ISFC, that means MF by IP as well as BSFC equal to MF by BP. Understood? ഈ ബി പി നമുക്ക് എവിടെ നിന്ന് കിട്ടിയിട്ടുണ്ട് ഓക്കെ ഈ ഒരു ഫോർമുലയാണ്. സോ ഫസ്റ്റ് ഓഫ് ഓൾ you have to find the IP from the equation for the mechanical efficiency and we can substitute a particular IP value in the indicated thermal efficiency and we will be getting the mass flow rate, okay, or the fuel consumption of the engine. Okay, so that particular fuel consumption of the engine divided by the IP given will be giving the indicated specific fuel consumption as well as the brake specific fuel consumption. മനസ്സിലായോ?
Yes, sir.
ഓക്കെ, ഇതിന്റെ സ്ക്രീൻഷോട്ട് എടുത്തിട്ടുണ്ടോ?
Sir.
Sir.
ഓക്കെ, ഇന്നിപ്പം തന്നെ ചെയ്ത് നോക്കണം കേട്ടോ. വിൽ ബി ടേക്ക് ദാറ്റ് മച്ച് ടൈം. ഇതിന്റെ എടുത്തു വന്നു. ഓക്കെ, ഓക്കെ മനസ്സിലായി. Just 1 minute.